the shock. Imagine pointing the most powerful infrared eyes humanity has ever launched into space at a dark 2-kilometer shard drifting in from the gulfs between stars, and watching a grid appear. Not a smear, not random pits, but neat rectangles and intersecting lines patterns that look eerily like a city seen from orbit. That's the claim at the heart of tonight's investigation. In September 2024, the Atlas survey flagged a fast inbound traveler that was quickly reclassified as Interstellar, only the third confirmed visitor of its kind after 2017's Oumuamua and 2019's 2I/Borisov. By October 2024, the James Webb Space Telescope had turned its mirrors toward the object, now labeled 3I/Atlas. And in the cleaned high-contrast data, something unexpected surfaced. Multiple teams ran independent image processing pipelines, hunting for artifacts and algorithmic ghosts. Each time, sharp edges persisted in a relatively flat belt near the equator networks of right-angled features between 50 and 200 meters across, covering roughly 8% of the surface. The raw physics of the body, meanwhile, sounded familiar: a mass on the order of 9, 5 by 10⁸ tons, an extremely low albedo reflecting about 4% of sunlight, and a spectrum dominated by frozen water methane and ammonia with complex organics typical of cometary material. In short, nothing manufactured in the chemistry, yet geometry in the topography. That contrast is the spark. Our question is not, are these alien blocks, but can known processes sculpt rectangles at this scale on an interstellar object? And if so, how? Before we chase answers, we need to map the terrain. First, the historical context. Oumuamua's elongated shape and non-gravitational acceleration ignited years of debate because the data were thin. 2I/Borisov, by contrast, behaved like a standard comet and calmed nerves. 3I/Atlas sits uneasily between them, comet-like in composition, but with surface order that resists easy analogies. Second, the chain of custody for the evidence. Webb's infrared observations in October 2024 were routine for a high-value target. The Space Telescope Science Institute teams then applied standard enhancement techniques to pull out low-contrast surface textures, and a trio of independent groups reportedly reproduced the same rectilinear motifs from different vantage angles as the object rotated. That cross-check matters because if a feature tracks with the body's spin and survives different treatments, it's less likely to be processing noise. Third, the negative control spectral scans show no exotic alloys or unnatural isotopic ratios. Radio telescopes engaged by SETI programs have not picked up periodic emissions, and time series analysis so far shows no dynamic rearrangements of the patterns that might hint at active technology. In other words, the techno signature box remains unchecked. So what's left? A short list. We'll test in this series large-scale crystallization in layered ices over million-year thermal cycles, contraction fracture systems producing orthogonal crack networks, slow self-organization in organics under constant cosmic ray flux, and exotic but natural environmental histories, like long passages through structured electromagnetic fields that imprint order into regolith. Each could be part of the story, but none yet predicts clean rectangles nested across scales and confined to an equatorial band. If you're feeling the pull of the sensational, you're not alone. Our brains are built to find order in noise, but the investigative path starts with restraint. We hold on to the facts: interstellar object 3I/Atlas, James Webb imagery, rectangular features 5,200 meters wide, about 8% coverage, equatorial concentration, familiar cometary chemistry, and we ask what physics can and cannot do under extreme conditions. Tonight we'll dissect the data, challenge the models, and pressure test every natural first explanation before we even whisper the word design. If these patterns are real and natural, our textbooks on surface physics in deep space are about to get messy in the best possible way. And if they aren't natural, what then? The evidence file. Start with the composition, because it's the quiet anchor beneath the hype. Spectroscopy shows a cocktail we know well from comets: water, ice, methane, ammonia, and a haze of complex carbon compounds spread across a 2-kilometer irregular body that reflects only about 4% of sunlight, a cold, dark traveler that would be nearly invisible without infrared eyes. That's why Webb was decisive, and why the first pass looked unremarkable, until analysts squeezed the signal grain by grain, and the rectilinear textures refused to vanish. To keep our footing, we reconstruct the workflow. The 3I/Atlas Webb campaign in October 2024 used multiple bands to map thermal behavior and surface contrast. Then 3 analysis groups working independently ran distinct deconvolution and denoising algorithms and compared results as the interstellar object rotated, confirming that right-angle seams tracked the body's spin rather than sticking to the detector frame, an important artifact check. Spatial metrics matter. The repeating features range from roughly 50 to 200 meters across, occupy about 8% of total area, and cluster along a relatively planar equatorial belt. Borders are unusually crisp, with abrupt tonal transitions compared to the softer fracture fields seen on 67P/Churyumov, Gerasimenko Europa's chaotic terrains, or Pluto's nitrogen ice cells. Chemistry does not distinguish the patterned zones, their spectra match neighboring ground, so the mechanism likely rearranges existing material rather than plating on something foreign. First candidate orthogonal cracking from contraction under deep thermal cycles. On Earth, cooling basalts can form hexagonal columns when shrinkage stresses distribute evenly, and polygonal muds crack as water evaporates, but right-angle networks of this coherence at 100-meter scales are rare unless stress fields and material anisotropy line up just so. Put differently, you'd need a rock-steady directional bias in the ice dust matrix to privilege rectangles over hexagons. Second candidate, macrocrystallization in layered volatile ices, water, methane, and ammonia. Each host multiple crystalline phases, and, in microgravity, plus million-year heating cooling large domains can grow. Still, most crystalline symmetries that broadcast at the surface favor facets and ridges, not a neat circuit board plan form, and they seldom lock themselves to a planetographic band without an external driver. Third candidate, non-equilibrium self-organization in organics under constant cosmic ray flux. Chemical reaction diffusion systems can paint ordered patterns from simple rules, but scaling those to tens or hundreds of meters and pinning them to an equator demands a persistent energy gradient and diffusion barriers that remain stable over eons. Fourth candidate, sequential impacts. Simulations show that swarms of fragments with similar velocities can leave linear strings of pits, yet you'd expect circular craters and overlapping ejecta aprons, not crisp nested rectangles with sharp edges. So why the equator? The simplest lever is rotation if 3I/Atlas has a spin rate that modulates insulation and thermal stress most strongly in a narrow belt. You could localize cracking sintering or sublimation scouring there. Add subtle topography, an ancient flattened plateau, and you might amplify the effect. And what about instrument pitfalls? Are we chasing algorithms? The teams anticipated that accusation. They rotated kernels, altered priors, and cross-validated with different point spread models. The geometry persisted. Meanwhile, early SETI checks found no repeating radio carriers, and compositional scans flagged no exotic isotopes, no obvious technosignature, no green flash beacon. If there's a NASA data delay, it is the ordinary lag of careful calibration and peer review rather than a smoke-filled room secret. Bottom line, the case file now contains a consistent morphology, a plausible equatorial forcing mechanism, and multiple natural hypotheses, none yet fully predictive. The next step is to stress test those models with higher resolution thermal maps and time-resolved observations during any Mars flyby geometry or favorable Earthline aspect, because only better pixels and better physics will tell us whether rectangles are an illusion of process or a new rule of nature. The debate zone. When news of the 3I/Atlas patterns broke across astronomy circles, the response split almost instantly on one side. Skeptics warned of the face on Mars syndrome, our species' compulsion to impose order on randomness, while others, cautious but intrigued, pointed out that dismissing every anomaly as pareidolia has historically delayed genuine discoveries. The pattern geometry wasn't speculative anymore. It had survived multi-angle confirmation and diverse filters. That forced a deeper question: could the interstellar environment itself breed order? Models from the Max Planck Institute suggested that comets traveling for millions of years between stars endure extreme temperature swings hundreds of Kelvin across short orbital arcs, creating violent stress cycles. They called it controlled fragmentation, a process where internal tension fractures the surface in a semi-regular lattice instead of pulverizing it. On Earth, columnar basalt forms from similar cooling differentials. In theory, an icy rocky composite could freeze and crack along hidden crystalline orientations, creating orthogonal grooves. But even those simulations struggled to replicate the precision observed. The next frontier was complexity physics. Researchers from Arizona proposed that non-equilibrium chemistry on irradiated surfaces might lead to spontaneous patterning, essentially the comet as a cosmic petri dish. Organic molecules bombarded by radiation could trigger slow self-organization, an echo of reaction diffusion systems like the Belousov-Jabotinsky reaction. Over eons, microscopic feedback could sculpt macroscopic order. Still, that elegant idea hit a wall of scale. Can diffusion gradients operating at micrometers produce networks measured in football fields? Other teams turned to magnetohydrodynamics. If 3I/Atlas had wandered through a region laced with structured magnetic fields, perhaps near a pulsar wind, or dense molecular cloud-charged particles might have aligned and hardened surface grains in linear bands. Yet, that hypothesis required conditions so specific they bordered on fantasy. Critics reminded everyone that Occam's razor still applies when extraordinary claims emerge. Start with ordinary physics pushed to its limits. And yet, the ordinary was struggling. The regularity of rectangles, their nested fractal-like hierarchy, the confinement to a single zone, all pushed known processes to breaking points. Philosophers of science began weighing in, noting how this event blurred categories. We rely on natural versus artificial, emergent versus designed. Some asked whether intelligence might manifest not through construction but through physics itself. If self-organizing laws can simulate design so perfectly, would we recognize alien intent even if we saw it? Researchers reopened their notebooks, quietly adjusting their criteria. Technosignature may not mean radio pulses or laser flashes, but persistent, improbable geometry beyond known physical bias. Others urged restraint, recalling Oumuamua's lesson. Its anomalous acceleration sparked alien rumors, only to find mundane explanations in outgassing physics. Webb's team itself has maintained professional skepticism, emphasizing calibration and incremental evidence. What makes this different, they admit, is the sheer reproducibility. The rectangles remain, no matter who processes the data. That leaves science in a productive tension zone, too organized to dismiss, too natural to declare artificial. As debate spread from conferences to online think tanks, public imagination filled gaps with talk of ancient civilizations, cosmic roadmaps, even alien probes disguised as comets. But inside labs, a quieter excitement took hold, the realization that this mystery, whatever its resolution, forces us to rethink how order emerges in the universe. Whether by fracture crystallization or chemical choreography, 3I/Atlas has become a laboratory for the physics of form itself. And perhaps that's the real revolution, not discovering an alien city, but discovering that the universe can build its own architecture. The final reflection. As the dust of speculation settles, 3I/Atlas continues to glide through the solar system, silent, dark, and indifferent to the storms of meaning we project onto it. What remains undeniable is this: the James Webb Space Telescope captured something real. Rectangular formations between 50 and 200 meters wide, etched into an interstellar traveler's surface, stubbornly resisting easy explanation. Whether born of fracture physics, crystallization, or a deeper form of cosmic self-organization, these patterns are a reminder that nature itself can outwit our categories. They challenge the assumption that order always implies intent, that geometry must come from design. In confronting this mystery, scientists are forced to refine the boundaries between chaos and structure, between coincidence and law. For decades, our exploration of space has relied on familiar expectations: comets, dust gas, predictable orbits. But interstellar visitors like Oumuamua Borisov and now 3I/Atlas have expanded that comfort zone into something far more unsettling and beautiful. Each object carries a fragment of a physics forged beyond our sun, a whisper from other stellar nurseries. Perhaps these patterns are not messages, but mirrors reflections of our own hunger to find meaning in the unknown. As future missions and simulations probe deeper, we may learn that the universe sculpts order everywhere, and that intelligence itself is just one more emergent pattern among countless others. But until then, the enigma of 3I/Atlas stands as both scientific puzzle and philosophical invitation. The telescope has shown us the geometry. The question is ours to answer. What do you think these patterns truly reveal, alien design or the universe's own way of thinking in shapes?